All right, so we typed in all the each individual piece. Now I'm going to type in the domains after the squiggly bracket. So x less than -2, it'll truncate it. X equals -2. Now that one's weird. I'll show you. X equals -2. It just actually disappears, that particular piece. The whole thing is there, but then when I put it in, it disappears. But that's because this was actually a coordinate. All right. So that one, you know, looking back on it, all you really have to do is type in the coordinate -2, 2. If I can actually get rid of some of this other garbage. Right. You don't need any labels. Right. X squared goes from -2 to 2. And 3x is going to involve a greater than or equal to symbol 2. All right. Keyboard shortcut for greater than or equal, less than or equal. It might not matter because you can just pull it on the keyboard right there. But if you like using a regular typing keyboard, hit the greater than symbol followed by the equal sign, and it'll convert it to a greater than or equal. All right. Little trick for you. The only thing that we'd have to account for here are the open circles. Anywhere where there's a less than symbol, we have to have an open circle. So that would mean at -2, 1. So -2, -1. Long press or click on the icon, the point icon, and change it to an open circle. I don't care about the colors. Don't waste your time with that. All right. The endpoint here, drag it up. You see that we should have an open circle. We should have an open circle. If you don't know what the coordinates are at that location, you could bring it in and estimate, or you can plug the endpoints in. -2 squared is 4, +2 squared is 4. So pop those in. So -2, 4, +2, 4. Long press on both of them to make them open circles. My mouse is kind of terrible here. So there we go. It's kind of scrolling at the same time. Now you see this one has an endpoint that would be a solid point, but if it's not an open circle at its endpoint, it's assumed to be a solid point. So you don't have to plot an extra point there just for the hell of it. If you want to put it there, by all means, go for it, but not at the expense of time for other questions. All right. Now, the other parts of this question say, so graph link, you put your Desmos link in there. If you're doing it by hand, then you would just type in here that you're doing it in the file upload part. So question 11, you're gonna upload a hand-drawn picture. Domain range interval where it's increasing, decreasing, constant, right? And any points of discontinuity. So what I would do, if I wanted to do everything on Desmos, I'd just start putting it all in here, and in Blackboard, I'd type C Desmos and then paste it, and just have all my stuff in the Desmos. That's fine. All right. But for the domain, we're going from the left, working our way to the right. We hit an open circle, but we catch the point here. Continue on, open circle, but we catch the point here. So we're getting everything. So the domain, if you want to type in a note in Desmos, it's got to be open quote, then type in what you want to type in. The domain is going to be paren negative. We use INF, INF. All right. For the range, the lowest value here is at a -1, and then we hop up to 0. So we have a -1. Then we hop up to the capital U looks a little nicer, lowercase u is fine too. Then we hop from 0, the y value of 0, up to 4. And then we pick up at 6, all right? So bracket 0, 4, paren, and then 6 to infinity.
you just do -1 to infinity?
Say it again.
Could you just do -1 to infinity?
For the range, no, because you have gaps between -1 and 0, and also from 4 to 6, there are some values that are not included in the set. So we have to break it up in this case. Yeah, so increasing, decreasing, constant. All right, so the next one would be increasing. So where is it going? Uphill from here in terms of x, starts increasing at 0 to this x value of 2. There's a break in the graph, but then it continues increasing from 2 to infinity. So here we could say 0 to infinity. All right, because on that interval, even though there's a break, there's no instance in which it ever stops increasing. Right, if you pick any point along that interval, it'll always be increasing. And that's because there's no break, there's no gaps in the x values. There is gaps in the y values, but there's no gaps in the x. And since increasing, decreasing, constant measures x values only, we're good to go there. For decreasing, it starts decreasing at this location, stops decreasing right here. So from -2 to 0. Constant is where it has a horizontal. So wherever it flatlines. All right, so that's all of this stuff here. So negative infinity right to this location, x value -2. All right, so negative infinity to -2, parentheses, because there isn't a solid point at -2. And this point in space doesn't have any of these characteristics where increasing, decreasing, constant, anything like that. All right. The remaining questions here, limit as x approaches infinity, as x approaches 2 from the left. We'll start off with as x approaches infinity. As x approaches infinity, we're going this way, following the graph this way. As x approaches infinity, it seems like y is going up forever. So that would be infinity. As x approaches 2 from the left, so here's 2. As it's coming in from the left, it's approaching this location. This location has a y value of 4. All right, so from the left, the limit doesn't exist at x equals 2, but from the left it does, and it has a value of 4. From the right it does, it has a value of 6. So we would say 4. If it said limit as x approaches 2 from the right, we would say 6. If it said limit as x approaches 2, period, we would say DNE. But it only said limit as x approaches 2 from the left. This last piece says limit as x approaches -2 overall, meaning from the left, from the right. Is there an agreement? So here's -2. From the left, we're closing in on this point. From the right, we're coming in to this point. From the left, we're approaching a -1. From the right, we're approaching a +4. Those are two different values. They do not agree. So DNE. The next one talks about graphical limits. So same idea, except you're given a pre-printed graph. You know, you're not coming up with a graph yourself. So you're just doing the same idea, except the graph is already given. So Desmos graph, it's just I'm giving you the Desmos graph, right? So 2 from the left. So here's 2. From the left, we're approaching this location, which has a y value of 2. 2 from the right. So following the graph, we're approaching this location, which has a y value of 4. Since from the left and from the right do not agree, it's DNE. As x approaches -2. Well, -2 is over here, right? From the left and from the right, we're approaching this location here, which has a y value 2 boxes up, that's 1 unit. And then the limit as we go out to infinity, which means forever to the right. So following this path, it appears to be leveling off at the horizontal asymptote, which has a y value of 2. So that would be my result there. So that one should be, I mean, it should be easier than the Desmos one in the sense that you don't have to create the graph yourself, right? But it's also less flexible because these are cut and dried. They're either right or they're wrong, right? Because the graph is already predetermined. Okay. Now the last one, I'm gonna have to zoom out here a little bit. Okay, let me see if I can do it this way. Yeah, I can do this. Oh, maybe too much. All right, you're gonna have a order the steps kind of question on the test. It's just a question of it's a question of which question will it be for, right? Is it going to be for a limit question, limit definition? Is it going to be for a derivative question? But I always like to do something like this just so you don't have to solve everything from scratch, right? So it says the following steps are out of order for finding the derivative of this. This is a quotient, all right? Maybe the question on the test will be a product. Maybe there'll be a chain rule, who knows, right? We would put it in the correct order. So we would take a look and say, okay, well, what would my first step be? You look at all the different possibilities here. Well, I would do low d high minus high d low over denominator squared, and away we go. So low is cosine, d high would also be cosine. So just kind of keeping that in mind, I know the bottom has to have a cosine squared. So I'm looking for something that has cosine times cosine and then a cosine squared on the bottom. It's like, oh, there we go. That would be step 1. All right. And then you could see this would be the high. And then doing a lot of scrolling back and forth, but the d low derivative of the denominator is negative sign. So it all kind of cleans itself up. All right. Now, the next step in the process, if we're simplifying, we probably aren't going to get down to the cleanest form of the answer yet. So it's probably going to be pretty messy. So I'm looking at one of these. Cosine times cosine is cosine squared. Okay, so it's probably one of these. If I distribute this, negative sign times a negative would be a positive sign. Sine times 1 is sine. Sine times sine is sine squared. So that would put this one next, if we distribute correctly. This one just seems like a rearrangement of this one, just swapping the sine with the sine squared. So that would be number 3. But that actually gets things moving pretty nicely because, oh, I hate myself sometimes. All right. F of x, this one shouldn't be there because that's the original problem. I must have copied and pasted it in somehow. So we'll call that 1 and just move everything down the line a little bit. Schlamingus. All right, anyway, sorry about that. Cosine squared plus sine squared is a Pythagorean identity. That's equal to 1. 1 plus sine over cosine squared would be this one. So we're at 4, so that would be 5. So now I'm living in this neighborhood, right? So I'd look at this. Okay, cosine squared, what's that equivalent to? Pythagorean identity, cosine squared is the same as 1 minus sine squared. So that would actually make this my next step. 1 minus sine squared actually factors the difference of perfect squares. 1 minus sine, 1 plus sine. So 7. And then finally, 8 would be the only one left over, but you can see that's what would happen if you cancel the 1 plus signs. All right. And so there it is. I apologize for that. That f of x should never be there, and it won't be there on the test. It shouldn't even be there for this one. So if that was the sticking point, I apologize for that. And so I'm going to stop the recording.